Hello and welcome to the 2026 series of the Euronaval Talks. If you're joining us for the first time, this is a series that was launched in 2023 by Euronaval to make sure that we keep the connection between different iterations of the trade show. Until very recently, relatively recently, our navies were able to deploy further away overseas and were able to count on allied ports for their logistics, for their refueling, and for staying away from their home ports for a long time. With events these days, we are realizing that this is probably no longer possible, or at least not with the same ease as we used to be able to count on. So what does this mean for energy autonomy on the ship? What does this mean for what kind of propulsion we have? What does this mean for what kind of energy we have at a time where systems are demanding more and more of the energy of a ship, with power surges as well as we get into confrontation? So without further ado, I would like to introduce you to my experts today, who with their very different backgrounds will be able to bring all of these topics together and hopefully, as I like to say, ask almost more questions than we're finding answers, because, well, this is the days that we're living in at the moment. So I will start with by introducing you to Jean-Christophe, who is the associate researcher at the FMES, which is the Fondation Méditerranéenne for Strategic Studies over in Toulon. Welcome, Jean-Christophe.
Thank you very much. Hello to everybody.
It's very nice to have you with us. Here with me in Paris, I have also Dr. Thomas Beard, Clean Shipping Service Lead at BMT. Welcome, Thomas.
Welcome, Alex. Thanks for having us.
Thank you for coming all the way from Glasgow.
Yes, yeah.
And also here to my left, I have also John Voice, Halo Program Director at GE Vernova, coming all the way from Bristol.
Rugby.
Thank you very much for being here. It's a pleasure to have all three of you. Now, Jean-Christophe, I would like to start with you because I know that you have been writing a fair bit on the issue of logistics and how to sustain a navy at sea. Is that right?
Well, I have a long experience of sustaining a ship at sea with my career in the Navy. And we have just thought with the FMES about the support that French overseas territory can bring to naval forces. And you're right, the difficulty we face in this new world is we are not sure that the countries we relied on before the different wars are able to support us. Just to give you an example, if you want to operate with the US on the war in Persian Gulf, you need to have a support. And if you stop on a country, perhaps this country will receive some missile or drone. And so it could be a difficulty for this country to host naval forces. And so you have to rely on some bases. And for example, for the Strait of Hormuz, France has two bases, one in Abu Dhabi, so inside the Persian Gulf, so you can't rely on to support your forces, and another one in Djibouti. But in Djibouti, you are very close to Yemen, and so you are possibly under the threat of missile and drones. And so you have to think more larger of that, and seeking for countries to help you. So you can have India. In East Africa, it could be very difficult. And if you go a little bit southern to the south of Indian Ocean, you have a French naval base at this place. And looking at all the overseas territory in France, for France, you have also naval bases in the Atlantic, in the South Pacific. And so you have a collar of bases able to support forces without relying on diplomatic agreement. I just want to stress a point. Energy and fuel is obviously very important for the ship. As you know, nuclear propulsion is one of the solutions, but you need very big ship, and it is not possible for all the fleet. And the necessity is not only for the fuel, but you have the fuel for the navy, ship engines, also for the aircraft, and you need also to have some food and for the ship. And it's a very old problem, but the autonomy is mainly limited by the capability of having food and having the capability of replenishment. And to do replenishment at sea, you need to have bases to support you, and you need to have ship to do the job of going from the port to the forces and provide the logistical support they need. And that is a big point. And so the reflection we have made in the institute in Toulon was to think about what could be necessary to improve the support we can have all around the world.
Yes, that's what, and we'll come to that later on in this roundtable. But at this point, you preempted my question, in fact, Jean-Christophe, because I was going to ask you, when we're talking logistics, you're right. You know, I mentioned fuel and I mentioned a little bit energy, but when we're talking logistics, we're talking about also maintenance. We're also talking about what we're seeing more and more as we're getting into confrontation. We're also talking about weapons. How do you replenish your weapons? How does that all work? So I'm assuming this is also what you were looking at in terms of French overseas territories being able to support.
Yes. Perhaps you have seen recently logistical support ship, French ship was replenishing not at sea, but at shore, a ship in Martinique in the French West Indies, and bringing the missiles and deliver the missiles to the ship, not in a main harbor in Europe, but in Nova Sea territory. And yes, you're right. You have fuel, ammunition, food, maintenance, or also perhaps all technical support for the data, for all this kind of thing. And it could be very easy to do. And we can see that US are delivering probably the aircraft carrier are delivering a lot of bombs and ammunitions on Iran, and they need to replenish. They have the ship, but it could be for European navies a big challenge.
Absolutely. Tom, I'm seeing you nodding along and scribbling away.
Yeah, I think energy is the big challenge, right? But it's not just about the current conflict, and we can look at history and read from that. It's always logistics is always the problem. But when we look at energy, we need to look at the future as well. And Jean-Christophe mentioned nuclear and how it can't be retrofitted. And yeah, that leads on to what we're going to talk about later, I think. But we've got to mirror what we'll try. At the moment, we align with the commercial sectors. So if we're in the middle of the Mediterranean and we need to deploy, we will get fuel wherever we can. That's not going to happen in the future as commercial maritime shift. So it starts to raise more questions about how are we going to manage energy in defence.
Because also, and correct me if I'm wrong, but if we're relying too heavily on fuel, as I believe we are right now, when we have crises like the one that is ongoing, and the price is going up, I mean, it's an issue of prices going up, but it might also be an issue of it not being worth it anymore for fuel.
Yeah, so you've got the price issue, but it's the availability, right?
Yes.
If it's not there, you can't get it, we can't deploy. And so it's how we manage that whole ecosystem. And it's also the costs. At some point, it's going to be a case of, well, do we fund a hospital or do we put warships in the sea? Potentially. And it's things like that. So we have to manage that. And that's what really raises these issues.
The issue of sustainability
of operations.
Of operations, yes, exactly. Yes, we have to be careful with the use of the word sustainability, I know. We're not talking about green shipping here, although indirectly somehow we are. As you said, it's coming from the commercial domain, but sustainable operations at sea. And from your point of view?
Well, I think also Jean-Christophe was talking about the logistics. As we look into a future fight, we're going to use more uncrewed vessels. These are going to be attritable. So where are you going to replenish not just your food, but your uncrewed vessels, and how are you going to get them there? If we're going to have large sensor and effector vessels that can be attritable, can sink, where are you going to pre-position these vessels? Because they may not be able to rejoin the task group from your host nation, because they may not be able to go on passage by themselves without some sort of force defense. So this pre-positioning of your force in the future, we need to think of small autonomous vessels under 24 meters and large 60, 70 meter vessels, which need to be pre-positioned, and host nation support is going to be so vital for that.
So one question I had for you, Jean-Christophe, as well is, I mean, we've had overseas territory for a very long time in France, and I can't imagine for a second that it was not already on our radar, so to speak, to use them as logistical bases. So what's changing now? Why your study now, and what's changing now?
Well, it's a matter of strategic landscape. And the problem of Europe, including UK, the problem of Europe, it's a little part at the end of a big Eurasiatic continent. And we are used to have our logistic background in the Atlantic with the US. As you know, US now, we don't know what is going on if we can rely on. And the strategic background of Europe, if you look for the map with the problem we have in Asia, from Middle East to East Asia, Southeast Asia, the problem we could have in Africa or even in America. The problem in America is more on narco traffic or something like that. And so the strategic depth of Europe is more at sea. And so you need support. And the French overseas territories are very well placed because it is a result of history. For example, the West Indies, it was when European countries were fighting for America. And so we have kept some territories. And so now we can think of using them as the strategical advantage, and not as something lost in the memories and from the history. It could be a strategic advantage if you have a worldwide look. So I don't know if everybody know where are our territories, but you have some island and bases in West Indies, so Guadeloupe, Martinique, and also in South America, sorry, in French Guiana, close to the Brazil, and also in the southwest of Indian Ocean, the big base of island of La Réunion, where we have a naval base, and some island and small bases in the Mozambique Canal, which is a very, very strategic place for oil and commercial shipping. And also some territories in New Caledonia, not so far from Australia and New Zealand, and also in Polynesia in Tahiti. And so all these bases are able to bring support on a broader perspective of strategic needs. So in Pacific for China threat, if there is one, in Indian Ocean for what is going on in Middle East and South Asia, and also Africa, and the territories in America. Just to help, we have the agreement of Mercosur. It could be very interesting to have a strategic point at this place.
Mm-hmm. Thank you, Jean-Christophe. We'll come to fuel and synthetic fuel in a second, but I wanted at the moment, since I have two British people with me at the table, I was wondering if you could tell me a little bit, France is not the only country that has overseas territories, so do the US and so do the Brits. Is this something that we're also seeing in the UK, looking more strategically at the overseas territories, or not yet?
I can't pin anything that I've seen myself. Obviously, Ascension Island was critical in the retaking of the Falkland Islands in '82. I think there are some strategic analysts that believe it would have been a lot harder if we didn't have Ascension Island halfway down the Atlantic for that. So the importance of your overseas territories, absolutely, I believe with Jean-Christophe. Obviously, currently in the news, there was a lot of talk on Diego Garcia, and that has a political ramification. So maybe that is the conversational point on why that is now coming up in conversation and how that is managed, with a lot of nations having views on it.
Yeah, absolutely. Diplomatically.
Diplomatically.
Or not. Yes, Tom.
No, there's not really much I can add to what John said. I think we do forward deploy units, and that's great, but that still links into bases in those overseas territories, and they are always used. You see it on social media when vessels go into ports, because yes, we are there fighting, but we're also there doing political missions. So we do a lot of that, and we do trade with everyone. So
that's a good point, Tom, because there's also the Commonwealth that, as well as overseas territories, the British Commonwealth has a close collection, and so there are some options. But I'm not seeing, unless there's conversations about the Commonwealth breaking up, not seeing that at the moment.
Yes, not to this level.
yeah, no, I completely agree.
So moving on to, okay, we've got these strategic territories, but not everybody does. So what does this mean in terms of, as you were mentioning earlier on, Tom, fuel may no longer be an option at some point for various reasons, for production, for costs and everything. So what alternatives do we have that are coming from shipping?
So, I mean, we've got one option where we can look to hopefully follow the commercial sector as they're starting to transition, right? That is due to their climate change issues, but it's not going to be a single fuel like we use at the moment with diesel. So that presents problems in itself. It's also then how we manage that. So we can produce fuel, we can make it synthetically, and it's how we do that. And there's a few options. We can have it forward deployed, land-based solutions that can then go onto our territories, as we heard from Jean-Christophe, and we can do that. But as we've seen in conflict across history, that kind of technology gets targeted. The Allies done it to the Germans in World War II, and it's happening now in current conflict. So we got to look at also having a solution where we have mobile assets that we can produce fuel on the move to sustain strike groups. That is my personal view of how we can manage this. It's a mixture, but I believe that Navy, Defence needs to take ownership where they cannot align with commercial. It's a bit different for, say, the Air Force, because aviation is all going synthetic aviation fuel, sustainable aviation fuel. And so because all airlines are doing that, we can go with that in an Air Force perspective. But in the maritime domain, and naval especially, we can't, because there is going to be a disparate mix. So we can't piggyback on one and hope that it's right. We need to actually take ownership. And when you look at vessels that we're putting in the water now, they're going to be operating for 50 years, potentially. It's going to be too difficult to convert those. So we need to have solutions in place that will sustain our operations. And if we have mobile assets, I personally think that gives us an operational advantage, at least from an energy perspective. We still have issues around solid state stores, though.
Okay, so if I'm understanding this correctly, as you said, the shipping domain has many different options. But what I'm hearing specifically is that, as you said, and I completely agree, ports can be, and as we've seen in the first roundtable of the 2026 series, can be quite vulnerable. So it makes sense to be doing this at sea, if you can, forward deployed. But I'm also understanding from what's happening in the commercial domain that not everything is safe to be done at sea. Is that correct?
Yeah, there are challenges if we do it at sea, but we got to look like we already do replenishment at sea. So whereas commercial, they do that, but it's nowhere near to the levels that we do in naval domain. So we can transfer fuel. And we also, in the commercial domain, they have FPSOs, so they have those production sites. Okay, they're refining crude oil, but that kind of technology exists, and even the US are already looking at this kind of technology, not to run a strike group, but to run the air wing on carrier, on some of their carriers. So they're looking at making synthetic aviation fuel at sea to run the carrier, the air wing on the carriers. So it's about that, but it's on a bigger scale.
Okay.
To run strike groups.
So what's synthetic fuel?
So synthetic fuel is basically, it's almost a replica of what we would be using. So it's fossil fuel diesel is normally about has a carbon chain of about 16-ish carbon atoms with hydrogen on it, and there's other chemicals in there as well. But we can just reproduce it. So it is a reproduction, so it is chemically equivalent to what we use at the moment. So you still have all the carbon atoms, the correct chains and everything else, so it matches, it's a mimic of what we use. It's just made from sources other than getting something dug out of the ground. So it's captured carbon, it's hydrogen from the water and things like that, and then we chemically combine those to then create the synthetic fuel.
Okay. So, because I was thinking, precisely you mentioned hydrogen, so I was thinking about these different options that exist. So those are part of the synthetic fuel conversation.
Yeah, so everything, if you're making it from a renewable energy source, and renewable energy doesn't just mean wind farms or solar panels, it's nuclear power can fall into that kind of category. It's having a source of energy, and then from that you can create these new fuels. And so they're like synthetic fuel, electrofuel, that's what it is. And it isn't just synthetic diesel is one option, synthetic aviation fuel, you could do hydrogen, ammonia, methanol. So the options are there. And it's the chemical process once you get the constituent parts to create those fuels.
Do we have a favorite at the moment of what could work on a Navy ship?
So for now, I would not be looking at transitioning from synthetic diesel. It is more energy intensive because it's the longer carbon chain, but it directly drops into what we operate right now for our vessels. And actually the way the chemical process works, one of the chemical processes that we can use works, is that we can then stop the chain or crack the chain at a certain point so we can create the aviation fuel that the flight wings need as well. So for me, that's what we'd want to do for the short term, at least, and by short term, I'm talking 2050. It's like a 50-year short term.
Short,
so it's not
long
really
term.
that short. But it's until we got the vessels, and then when we look at moving, because it's going to take time to transition entire fleets across to other fuels. And then if we go into that kind of domain, it's how we manage naval fleets when they're mixed fuels, which is a big challenge.
Okay. John, you wanted to add something about that?
No, I think it is. I think it is the challenge we need to address. We should be using oil for things that only oil can do, like making plastics, etc. And if we can create a synthetic that will do the job, that actually is quite a bonus. I do think that microreactors have a role at sea. I see some commercial companies starting to fit them so they can fit in the size of ISO containers, and perhaps there's another alternative there. But I think your question and Tom's reply is key. We need to kind of select one and move down. I don't think for a military vessel, ammonia is going to be the way ahead. There are others that I think we can discount, but I think there are a few in the race, and the strategic decision is which one do we go for, and then stick with it, because once you make that decision, it lasts for 50, 100 years as fleets transition to it. It's really a key strategic question we need to resolve.
And one question this is making me think of, and I wanted to check with Jean-Christophe about this. You know, we're talking about the ports, we're talking about strategic, overseas territories. I'm thinking if we start looking at different fuels, we might also want to be looking at availability of those fuels in those different bases, and also whether that changes our port's infrastructure.
Well, it's really a big challenge, but I can give you two examples of what is going on. There is a project in Guadeloupe, so in West Indies, to have an hydrogen farm at sea with windmills just to produce the energy and to convert water in hydrogen. So you have possibilities in these places because you have a lot of water, obviously, and a lot of natural and renewable energy. And the second example is in La Réunion, where the electrical plant was with diesel, and it has been changed in colza oil just to be greener. The problem is the colza oil is coming from Europe, not from the place, and so it is a strategic choice, but it is also a way of thinking of the whole chain of production. And if you want to have autonomy at a place, you need to have all the resources to have the chain at the place you want and to multiply this chain at the different places. And so, well, I agree with John. It's really a strategic choice. A lot of invest because you have to invest on the ship, on the new ship, on the bases, on the production, on the different places, with a limited room to do that. At the moment, you have to rely and for economic reasons also to expand this production and to propose to other ship or to other countries or something like that. Otherwise, you are free from oil, but you are not financially free.
Yes, exactly. And as you were saying, the whole chain as well. How does this work? I was seeing, yes, Tom, you had...
Yeah, so I think for me, it's not one nation. I completely agree. It's not one nation doing it on its own. It's a multinational grouping of nations combining to do this. I mean, you could bring in Germany with Evolence, who make some of these plants. They've got a plant that makes synthetic diesel, not fully synthetic diesel, but synthetic diesel petroleum in Qatar. That's just converting natural gas into liquids. So that kind of thing already works, and there are nations that are doing this. The nuclear issue, microreactors are great, but they're not going to be big enough to supply the energy that we want, potentially. So some of the commercial ones, especially the ISA container size, are like 5 to 10 megawatts electric. That's not enough to supply meaningful power to run an entire ship. And we've got to try and fit it in a ship that we've designed on the retrofit side, designed to run on diesel. The new build vessels, we can incorporate that, but we need to pick a technology. And I agree with John completely. We need to pick the technology, and if we're going to have microreactors on board, we need to pick the technology we're going to do, so that then we can actually make it work across the whole alliance, to be honest.
Okay, so we started this conversation by saying, we need to have our own ports, and diplomatically things are becoming complicated.
Yeah.
But now you're saying that when it comes to fuels, we're working on this as an alliance.
So you could do it on your own. You've got to do the economic numbers. You can look at the forecast for how much diesel's going to cost. Look that over your fleet or over your strike group, and then go, right, it's going to cost me over the lifespan of, say, 15 years, I could be looking at £15 billion. Okay, how much is one of these assets going to cost me? Well, it's going to be cheaper than buying diesel. So then you've got an economic case. So then there's an economic case to do it, and that's just on saving money, never mind all the money that goes into the economies and local areas to boost things as well. But could a nation do it on their own? Probably. Would it be better doing it together? Most definitely.
Yes, exactly. So, John, when we started this roundtable, you also mentioned, as you were saying, fuels is one part of the conversation, but the other part of the conversation is all these power surges. We're talking more and more about electronic warfare. We're talking about a vast array of sensors that require a lot of energy. We're talking about unmanned systems also that are going to go on these ships and that are going to need charging. Part of the conversation we often forget to have.
Yeah.
So what does this mean?
So I think the realization of putting this together is that the power in a warship is going to be more important than its speed or its caliber of gun that we used to play top trumps with and try and decide who had the most powerful warship. I think the most powerful warship in the future will be the 110 megawatt warship compared to the 50 megawatt warship, because the future, I believe, will be these energy resources, as you mentioned. The idea, and we're seeing it in Iran at the moment, the idea of single-shot munitions for defence is flawed if others can throw at you more. And with the advent of drones now, you can swarm attack very easily in a way that was too costly before with weapons. Now the economics of war mean that you can fly a drone attack and overwhelm a ship's single-shot supply of propellant missiles, solid propellant missiles. What you actually need is the ability to constantly defend yourself and attack. So the idea of directed energy weapons, whether they are lasers, rail guns, both of which are in existence at the moment. The Royal Navy's planning on putting a track and fire laser on a Type 45. The Japanese have a rail gun that they are testing, but also other weapon types that exist, whether it's sonic, whether it's any future weapon. I think what's really important is the weapons that we'll be using in 30 years' time, I don't think we can predict yet. We couldn't predict the good old iPhone analogy of 20 years ago, that your record player, file of facts, and everything would be in your pocket. You know, that would blew our minds. Well, can we now predict the future? The only thing I can predict the future is it's going to be electric, and it's not going to be powered through a gearbox. So how do we now prepare for weapon systems and sensors we don't know about, but are going to require more power?
Okay, so when you say it's not going to be the gearbox, you're talking, as you were saying, we're not talking propulsion, but we're talking about everything else that goes on a ship.
Yeah, often when we talk about this topic, we talk about power and propulsion. I think what we need to drop is the second P. We just need to talk about power. And the loads will be different than they are at the moment. Currently, the largest load is propulsion. Well, especially for an uncrewed vessel, the largest load may be the effector that is on that vessel. That could be, or a number of them. Say, track and fire is circa 300 kilowatts, I think, 300 to 500. Well, if you had 3 port, 3 starboard, you've got 6 of them. If they're all operating at the same time, which is probably likely in a swarm attack, that's a large electrical load that may be greater than the propulsion load. So we have to change our perspective and realize that electric power is going to be the lifeblood for the war part as well as the ship part, and I think that of a warship, and I think that's the change that we need to create in the future fleets.
So what does that mean? What's the solution? How do we do this?
I think the solution is to install a ship's grid that can accommodate whatever the future may be. Very simple, very glib, but we've done it before. This nation, the UK and other nations have national grid networks that were established when filament bulbs lasted 6 hours. And that was the height of modernity. Now they're still supplying power to data centers, which at that time of filament light bulbs no one could have thought of. So the infrastructure was there and had been upgraded to be able to, well, how do we do that on a warship? And the answer is to create the network in there, in the warship, where power can be used anywhere within the ship and isn't dedicated through a gearbox and can't be used anybody else. You have to be able to distribute that power to wherever you want it to go. An example being AI is hugely power intensive, as we know. Does anyone think we're not going to fight future wars without AI? So AI is taking 800 terawatts of power at the moment worldwide, a huge figure. So what's that going to be in a warship? Well, it's got to be at least a megawatt, and you're probably going to want 2 or 3 of these data centers. So you port and starboard and center. So you've got 3 megawatts of power that currently we don't look at. So there are going to be future loads we can't predict, but if we don't install more power than we currently need, we're not going to have the fighting edge.
Okay. I wanted to give a chance to Jean-Christophe also to fire back at this, no pun intended actually, because I know that the French Navy is amongst the first one also to deploy data hubs on board its ships. So are we looking at power, and does that mean anything also for our overseas territories and our infrastructure?
Oh yeah, it is a challenge. I remember it was 20 years ago, just modifying a French ship just to update the system, and I decided to put a digital system to manage the data and the documents, only PDF documents. It was a big challenge to have the energy to do that on a whole ship. So now with all the hubs, well, you have to adapt on what you can do. The new ship now have a lot of power because you have mainly electrical engine for the propulsion, and so you have more power on new ships, and it's very interesting. But at the time, it's always the same. You have a limited room to put equipments, to put crew, to put food, fuel, whatever. And at the time, you have also to count on the power you have on board. And at the moment, you have to say stop. For the bases, it's also a challenge because the problem of French islands are mainly they are very isolated, so they have to produce their own electricity. And if you add some new equipments and some new ship, and you have to provide, because for decarbonation of the ship, you have to connect the ship to the harbor. So you need a lot of energy to do that. Well, it could be very challenging, not only for the ships by themselves, but also for the bases and the territories able to welcome the ships. And I would like also to add something on the unmanned system. Mainly you have batteries, so you have to reload the batteries, but also you could have some other energy, because you can have, for example, some surface vessel, USV, unmanned surface vessel, and you can use diesel for the propulsion, or hydrogen, or I don't know. But if you multiply the needs of different energy, it will be very, very difficult to do.
Absolutely, yes. I mean, surface ships, we also have solar, but yes, when we start talking about underwater unmanned systems, that become, again, a whole different conversation. Tom, I wanted to give you a chance because, as Jean-Christophe was also mentioning, the power, the need for power. Yeah,
the need for power. I mean, the biggest problem is that even now we design a vessel for a set of requirements for an operation, and almost as soon as it enters the water, it's doing something completely different. And it links to what John said. We need to have that ability to manage the energy, and I think it's design it differently. Okay, we've got this energy demand that we think we're going to have. Let's decide a percentage that we need to put on top of that to account for things. But then we're looking at, are we carrying extra weight? So it's that trade-off between some of the commercial vessels that we have to design for future energy is designed for but not with. So design it so that it's easily adaptable, and so we can add something that will generate more power when it's going to be needed. You have the space there so that we can operate slightly differently. And then when we look at uncrewed vessels, actually then is there the chance that we can look at different fuels? And then we can use what's readily available in an area that we're operating. So then we can look at changing it. But there's still challenges with that, though.
Okay, so we have a long list of challenges. John, did you want to?
Well, and the size of the uncrewed vessel. So if it's a smaller one, like Jean-Christophe is saying, you can use batteries, but you're still going to need a charger. And if you look at, say, one of the fastest chargers, Tesla, that's 250 kilowatts. That's a lot. And if you have a number of those, that's another megawatt quite quickly that currently we don't have. But if you're looking at larger vessels, as you're saying, you can perhaps play with the power a bit more, but every person you're taking off, you're going to need AI to undertake their roles, navigation, engine control, maybe the fight, depending on whether the protocols allow. But all of those are going to add more power, but you don't need toilets, a galley, and other bits. So there's a trade-off, but I think the trade-off is not going to be to our advantage, and we're going to need more power in these vessels. And therefore, if you're going to want to keep them small, you again come back to you need power to be able to distribute it everywhere around. And an all-electric is the only way you can do that. So we've got to move from mechanical solutions that are still being produced and go to an electrical solution that allows the power to be distributed. And I'm reminded with the submarine behind you, how do they move in the future? How are they fight in the future? Putting power through water is quite hard. But then that means you're not reliant on X number of torpedoes in the submarine, so it could fight for longer. They've got unlimited energy if they're nuclear, so they've got a lot of power, but they haven't got a lot of space. And it's not a topic that's being discussed, but how do you introduce energy weapons underwater, and how do you manage those powers? It's a fascinating area that is going to really develop.
Okay, we don't have time to go into this, but I do want to ask the question nevertheless. Energy weapons in a submarine, how do you do it? Because light doesn't travel very well at long distances.
No, I genuinely have no idea. I was just inspired by your picture behind. But there will be clever people out there that whether it's the operation of a torpedo in some way via electric, so it can go faster, further, perhaps, or whether it's some electronic disruption mechanism. I have no idea. But I go back to the iPhone. We had no idea that was going to be created. What I'm saying is there will be clever people who would go, this gives us the ability for an attack submarine to keep attacking because it won't run out. Therefore, people will, where there's a need, someone will develop something. And how do we create the power for that? It's not going to be mechanical. Yeah. That's all I can predict.
Okay, where there's a will, there's a way, as they say.
That's necessity and war. It tends to produce these kind of things.
That's true. Gentlemen, we're coming sadly to the end of our roundtable, even though I know there's so much more we could discuss. So to conclude, I just wanted to ask each and every one of you, and I'll start with you, Jean-Christophe. In a minute, if there's one or two priorities that we need to look at when we're talking about autonomy at sea and how navies are capable of sustaining themselves for a long time.
Well, in 1 minute, develop support fleet. You need to have a replenishment at sea, you need to have a maintenance ship at sea, you need to have a logistic support fleet.
Well, that's less than a minute.
And bases. And so you have to rebuild, develop the bases to be able to welcome these ships and all the fleets, just to be able to have a logistic line from your base, autonomous base and national base, and European also, because we welcome our friends, to support your operations. Sometimes you can have 2,000 nautical miles from a base to a force. It's necessary to have these ships to do the job.
Yes, and I'm thinking there's quite a fair bit of work to be done on our ports infrastructure at the moment for the navies to be able to accommodate this.
Yeah.
Yeah. Tom, what about you from your point of view?
So from my point of view, I think we need to address the problem now. Let's not wait a few years until it's too late and then we're trying to come up with a solution when actually there are solutions that we could start investigating and exploring. I think And what underpins that is like there's a doctrinal shift potentially. We need to look at how we change doctrine, how we want to operate and things like that. But with that comes the realistic analysis of actually what are we going to want, how much, have an idea about what we're going to need, so then we can actually put solutions in place, rather than people trying to potentially guess or use public information. I appreciate if you use public information, we can talk about it. If we don't use public information, we may not be able to. But there is a fundamental thing that we need to address the issue. Right? Energy is a major problem in the whole of Europe. Only one nation in Europe can produce enough crude oil and refine it to run itself. Most of Europe runs at a deficit across crude production and refining capacity. So we need to address this right now. And actually, let's not just keep kicking it down the road and waiting for the next person who's in post or the next government that's in post. Let's actually start addressing the problem set.
So when you say there's a doctrinal shift, we're talking also about how we deploy, what we deploy, how we employ.
Jean-Christophe said, it's that logistical footprint, it's everything. It's address the whole problem. We need to change. We can't keep relying on what we've done because the world is changing drastically.
Yeah.
And actually it underpins, it's all the way back, history teaches us everything. I know the world's changing, technology is advancing so quickly, but there's a lot of lessons that have been learnt that we can still leverage. So we don't make the same mistakes again.
Okay. I would like to hope that humans can learn, but history doesn't always show that either. John, you get the last word.
So in concert and parallel with what Tom has just said, once we understand the fuel that's going to cause the generator to turn, it's about then an energy strategy that matches the production of energy with the war part of the warship, match energy with weapons, sensors, suppliers and other equipment, so that you can then look forward into future warships to what they may need. Then realize you're going to get it wrong and install 2 to 3 times the power you thought you're going to need, because power is only going to go up. I don't think that whilst we will become more efficient, I think that efficiency will then be overtaken with greater lethality. So power will go up, come with an energy strategy, implement more power than you need, and design the ships, submarines, and quite what will happen with aircraft or land is another person's problem. But I think that will give you then the ability to incorporate future weapon sensors that we haven't even imagined yet, but we will need, and there must be a Star Trek joke in here somewhere, but I think we will be using weapons that we can't think of at the moment in the warships we're producing today.
Yeah, absolutely. Thank you so much. Thank you to the 3 of you for being with me today, either personally or virtually. It's been an absolute pleasure. Again, we've raised a lot of questions, but I think all of them absolutely necessary for understanding how we fight tomorrow's wars. And this concludes the first series of 3 roundtables for the Euronaval 2026 series. We have discussed hybrid warfare. We have started going into confrontation, where we started talking about weapons and doctrinal shifts. And stay tuned for the second series of 3 roundtables where we'll go actually into the heart of combat. But for the meantime, thank you so much again, John, and then, Jean-Christophe, and also Tom. It's been a pleasure, and I look forward for the conversation to continue.
Thank you for having me.
Alex.
Thank you.
Okay, thank you very much.